Need a computer. Nice talk.
Good evening, all.
Hello.
Hi.
Good evening.
Good evening.
Consultation that I refer to is going to be.
All right. Good evening, everyone. Welcome
Good
to.
evening.
Yes, ma'am. How are you? I hope you're good.
I'm all good. How are you?
No, I'm good. I'm good. That's great to hear. That's great to hear. All right. So I think most people they managed to come through. So just waiting for the other guys, just to log in so that when we start, we all start when everyone is here. So just apologies. I think you might hear I think a funny sound in the background. I just have my heater on, it's a little bit cold. So if you can't hear, then I'll just tell me. I'll have to turn it off. But if you think that
No, we
it's not,
can't hear it.
oh, we can't hear it. Perfect then. Perfect. So that's good. All right. So, all right. Let me share. So last week we did an intro. For some of you guys, I think you already know who attended. So today, I think let's move on to the first slides. The first slide of many slides. All right. Okay, let me see. Trying to look for. Okay. All right. So you should see a full screen, right? So my name is Kuda, for those that are coming in for the first time, of which I doubt that. So I'll be the one taking you for stats. So this is now the first official lecture for states. Last week was just an introductory. So I said I'm going to repeat some of the things, in fact, everything that I said last week. So now we are starting afresh again. All right, so what we're going to look at in this slide, not this lecture per se, because I don't think I will cover everything, but we'll talk about what is statistics, type of statistics, data presentation, then maybe first part of measure of central tendency. All right, so statistics, basically, it is a way of gathering or organizing and interpreting information from the group to help you make sense of it. Or basically, the keywords there is you collect information, right? You analyze the information and then you interpret the information, right? So the statistics is all around you. As long as you are in a field where it has numbers, right? You here and there you see numbers. So chances are there is stats. So you guys are doing business management. So when you're talking about income, when you're talking about profit, when you talk about turnover, level production, forecasting, whatever you're talking about, sometimes you may need to use those figures for stats. So stats is all around you. So it's very important to have an understanding of statistical reasoning. And it's very important, again, to be able to interpret the results. Because if you are able to do a statistical model and you are not able to interpret what you have just analyzed, then it's going to be a problem. So the reason why this module is there is because when you, as business managers, are making a decision, you don't make a decision by instinct. All right. You don't say, my gut is telling me this is the best decision. You don't do that in business, right? So, as a business manager, you want to make what is called an informed decision. I think some of you guys have heard this term before, right? So when you are making a decision as a company and you're a manager, right, and you're trying to convince whoever you want to convince that this is a good idea and things like that, you will need proof. This is where statistics comes in. So if you like, I gave an example last time and says maybe you want to change a strategy, right? But maybe you know the sales are not performing very well and you want to change the strategy. You can't just come and say, guys, we've got a board meeting, everyone just come. You know what? We're changing the old strategy to a new strategy. People will be looking like you, but what are you trying to say? What is the proof that it's not working, right? So you need to bring forth the data, interpret for them. Then they'll be like, oh, now we see. Then they'll say, okay, I think there's need for us to change because the data is telling us that we need to change. So this is where it comes in now. So statistics is the gathering of data, classifying of data, summarizing, interpreting, and drawing conclusion from the data. So this now, all of this, you're doing it to facilitate what we call the informational presentation of data to support decision. So when you want to support a decision, right, then you need this type of information. So there's a way that you need to present the data. That's another thing that we're going to talk about. So when you have done your analysis and now you have interpreted it and now you want to present it to the audience, there are various ways of presenting that data. All right. So before we go to the data presentation, let's look at the two types of statistics that will be in this module. So the first type of statistics that we're going to deal with is what we call descriptive statistics. Now, the word descriptive statistics is more like self-explanatory. Why? Because it's statistics that tries to describe the data. So basically, this type of stats that summarizes and describes the data using some methods, like you can use frequencies, you can use percentages, you can use measures of central tendency, you can use measures of dispersion or shapes of a distribution, depending with the type of data that you are dealing with. But basically, what you need to understand is descriptive statistics describes the data. These are numbers or tables or whatever it is that describe the data. Then inferential statistics now inferential statistics, this is statistics where you make what we call inferences. That's why it's called inferential, where you make inferences or where you generalize about the population from which the sample was drawn. A very good example that I gave last week was I think there's a government entity or whatever. I don't know if it's a government entity or what. There's a body, right? That call themselves States SA, something like that. So they they collect data and things like that, right? So let's say maybe unemployment rate there at states, maybe let's say it's 10 or 20%, whatever it may be, right? So for them to come right to a conclusion to say the whole country, the unemployment rate is 30% or 20 or 10, right? What happens is they wouldn't have gone to each and every person in South Africa and ask whether are you working or not. Are you qualified to work or things like that? No, that's not what they do. So what they do is they go to a certain place, right? So maybe they may have a certain place that they go, like they go maybe in Gauteng, in all provinces, they just take a sample. So they take a sample from each and every province to be very accurate. So maybe they just choose maybe cities in each and every province, right? And then they take sample in certain places in those cities. Then what they do is the data that comes out from those sample of the cities in each province, they compile it, the percentage that they make, they infer it or they generalize it to the whole population of South Africa. That's why it's called inferential statistics. So it's statistics that you are doing on a population, but you are not including everyone in the population. You just take a sample. When you take a sample, you generalize it about the population. All right, so I got you. I hope you got it now. So we're going to do statistics that cover descriptives, and then we're going to do statistics that cover inferential statistics. All right, so we're going to cover both branches. Now let's go to data presentation. So the information obtained from a statistical analysis is meaningful to business managers, because remember, you're business managers, right? Only when it can be interpreted and communicated effectively. So the whole point of doing a statistical technique, as the modeling, is not for you just to be having figures that you can't interpret. Because remember, we're saying you want to make a decision, but the decision that you want to make is informed. You need to prove to the other guys that you are sitting with on the same table that we are making this decision based on this data. So you should be able to interpret the data. Not only interpret, because you can interpret the data and fail to communicate it. So you should be able to communicate the data. So what are we saying? So you need to understand, what am I going to present before the people? So what type of presentation can I bring out these stats? So that's what we are going to talk about now in data presentation. The various types in which you can present data that you have statistically analyzed, depending with what you want to achieve at that particular time. So maybe you may need just to have an average, or maybe you need a graph, or maybe you need a table to communicate whatever you want to communicate with. But the whole point is you should be able to interpret and communicate what you have interpreted or analyzed. So it is customary to convey such information through the use of summary tables or charts. So you can use tables or you can use charts, right? So tables and charts, they convey information more vividly and quickly than a written report. So sometimes you don't need to write your results in a report. You can just put it in a table, or you can put it in a chart. It's easy for people to understand than for people to read, long paragraphs when you could have presented it in a rather nice way. So one such compact or efficient way of presenting data is in form of a table. So using a table, the data often is much clearer than writing all the information in a paragraph form. So let me show you using this example. So this is the beauty of using tables. So can you see on the left side, this is the information. So I need to read all this information to understand what they are talking about. But on the right side is the same information, but in a table. All right. So just looking at the table, I can already tell that, oh, okay. Oh, so without even reading, I can tell, okay, so those are universities, right? So those are the ranks in the whole world. Then maybe those are the people that have the holdings, and maybe I think I think it should be research libraries. I think something to do with the research libraries, the holdings in the research libraries, right? So, but on the left side, that was the same information, but I could have taken time and even not, I could even not, maybe I could have not understood what, this whole paragraph is talking about. So that's why we're saying this is the same information, but this is depicting the information better than this one. So it depends. What information do you want to convey? Do you want people to sleep in a board meeting? Come with come with your stuff just written in paragraph format. People will yawn and sleep. But if you come with something like this, people will be engaged, right? So that's what we're talking about in terms of data presentation. Now let's look at our first type of presentation of data that we're going to look at in this study. So there's something called the frequency table. So what is a frequency table? So a frequency table, it's a table, right, which shows the number of occurrences of a variable falling into a specific range or category. So what it means is the table will have ranges, it will have categories, or we have what we call class intervals. Then you are now grouping your data based on the category in which the variable fall into. Okay, let me explain this using the example there. So, example within your study guide says, consider a group of 47 males, right, of various ages. So, these males, their ages, they vary, right? Then 12 out of the 47, their ages are between 20 to 29. 13 are between 30 to 39, 7 are between 40 to 49, 8 are between 50 and 59, while the rest are between 60 and 69 years of age. Now, if we are to depict this same information in a frequency table, you can see that we've got two columns. So the interval now is what we call the class intervals, right? So what is a class interval? So a class interval, it is a range, right? Or a category, right? Or it's just interval. So you would have divided, let's say, your one variable into what? Into classes. And then now you are grouping whatever people or your data based on those categories. So like in this case, our interval will be years. Then we've got group of years, 20 to 29, 30 to 39, 40, 49, whatever, and things like that. Then under 20 to 29, we're told that 12 are under that group. Then you come and you write the number of males that fall into that group. Then you write the number of males again that fall into this group, the number of males that fall into this group, the number of males that fall into this group, the number of males that fall into this group. So what you would have done here is you would have grouped everyone based on the age group that they fall into. So you want to find someone in two groups because you can't have a person who has two two ages, or is it two ages or two, or what? Yeah, I think so. You can't have like I'm 30 and 50 years old, years of age. There's nothing like that. You only have one age, right? So obviously, if each person will have to fall into a certain category. So you have already grouped them. So if you are given data and they tell you to group, this is how you do it. So they'll give you instructions like what we did, what we did last week, or what we're going to do in the assignment, where maybe you are given first raw data and then they ask us to group it. This is how you group it. So you group it using what we call a frequency table. So this might also be called a frequency distribution. So it's the same thing. Frequency table, frequency distribution is the same thing. It's the table that is used to group data. That's what you need to understand. So the basic of the frequency table is two. The basic, I'm not saying every table must be like this. So the most basic frequency table must have two columns. It must have the interval and it must have the number of, let's say, in this case, it's the number of males, or what they call frequency. So the frequency at which the data fall into that into that range. Like in this case, so the frequency of males, right, that are under this age is 12. The frequency of the males that are of this age is this. So that's why it's called frequency. So this one will be frequency. That's why it's called a frequency table, basically, right? So now, having this table, we can immediately make the following conclusion, right? So one, from the table alone, you can see that the majority of males are young. Okay. What is young? So if we define young by saying any man below the age of 40 is young, then you come and say, oh, we see, because 20 to 29 and 30 to 39, this is where most of the males are. So the majority of the males are young. Then you can tell most of the males are between 30 to 39. Why? Because this is the class with the highest frequency. Then if you add all the number of the males here, they should give you 47. Why? Because what we just did is grouping each male into the age group that they fall into. Basically, that's how you do it, right? Now, there's another variation of the frequency table. So I told you the most basic table, it has two columns, which is your class interval and your frequency. Now, if we add another column called the cumulative frequency, then we have what we call a cumulative frequency table. So let me explain to you what cumulative frequency table is. So let me explain it using an example here that is within your study guide. So let's consider a class that consists of 100 students. Suppose the teacher gives the entire, class a statistics test, which is a maximum mark of 100. Upon marking the scripts, right? So when the lecturer was marking the scripts, which are in no order whatsoever. So the scripts, when lecturers are collecting scripts after writing a test, there will be no order. So they'll be like, who's finished? So they'll collect maybe based on who finishes first. So people will be seated in a random, what I'm saying, guys. So people will come and maybe they'll just put their, their scripts in no order whatsoever, right? Then he puts the marks into a table. So when they were writing now the marks on the table here, remember, this is not a frequency table. This is just a normal way of recording the data, right? So this, you can see the data is not grouped in any way. It's just okay.
Raw data.
Something just disturbed me here. All right. So it's just a way of just trying to write down the data. All right. of writing down.
Can you say it's a collection just of the raw data?
Yes, yes, exactly. That's a collection. That's a perfect term there. So that's a collection of raw data. So this is just raw data in a table. So you mustn't say it's grouped because it's in a table. So the raw data also can be put in a table. Because you can see that it's not what? It's not grouped. So this is collection of raw data because it's not grouped. Then, so you can tell now, this is the first student and this has to be the 100th student. So upon examining the data, you can calculate what is called the range. When you are given basically raw data, you can calculate the range. Basically, when we're talking about the range, you are just saying the maximum value minus the minimum value. So in this case, the maximum mark that the person got was 90. The minimum mark, right, that the person got was 8. So it shows how the data is spread, right? So now, having said that, now how do we, let's say we want to group the data, right? Based on the intervals of marks, let's say from 0 to 9, 10 to 19, 22, 29, and things like that, right? Where we are using a class width of 10, right? So let's see how do we populate, you know, the first two columns, like let's say the interval and the frequency. So these are the intervals that we have put, right? And then these are the frequencies that are the number of people that have got marks that fall into that. So what you need to do is you come and you check here how many people. So let's say the first class. So the first class is 0 to 9. So you come and check how many people have got a mark between 0 to 9. So you can check here. I don't have time to show you that, but you can check. You see that it is 1, 10 to 19 will be 2, 20 to 29 will be 5, and so like that, and things like that. So if you add all of these frequencies, they must give you 100, because remember there were 100 students that took part, right? But already we talked about this. I showed you how to do these two columns. Now, what I want to show you again is what we call a cumulative frequency. So when we're talking about cumulative frequency, we are saying you are adding frequencies together as you go along. Basically, you are accumulating the frequencies. So it's more like a person who's accumulating, let's say, things in a basket. So you start with 1, and then, you know, as you collect, your basket is, the number in the basket is increasing. So that's the same thing. So what you need to understand when you are calculating cumulative frequency distribution, there are 2 ways of doing it, but I'm going to show you. I'm just going to show you the first one, the longest one. Then the other one will show you when we do examples in the Excel sheet, right? So for now, I'm just explaining using the mouth. But normally, when we're dealing with the frequency table, we do it on an Excel sheet. Because remember, I told you I'm going to show you ways of, you know, making life easier for you guys when you're calculating some of these things. But the longest way of doing it is you come on the first frequency. Remember, here, this is the first class. So the previous class here, there's nothing here. So there's 0 because there are no classes there. So what you do is you come on the first class. So you say, what is the cumulative frequency of the first class and the previous class? So the previous class is 0, right? So you can say 0 plus 1, you get your 1 here. Then you come on the second class here. On the second class, what are the frequencies before this class, and we need to add them to this number here. So you say we've got 0, we've got 1, and we've got 2. So you add all of this, and then you get your 3. Then you come to the next class, which is 5. Then you add all the previous frequencies plus this one, right? So if you say 0 plus 1 plus 2 plus 5, you get 8. Then you come on the next one, you add this one with all the previous ones, right? Then you get 14. You come on this one, you add this one and all the previous ones. Then you get 43. Up until you get to the last one, then you get 100. So that's the first way of doing it, right? How do we get the do we choose? Okay, I'm gonna explain that one about so normally let's say in the final examination, your final examination, you don't have to, okay, the only way that you can calculate the class width is you use these intervals here. I'm going to show you after I explain the cumulative frequency, right? But for your assignment, it's a bit different because your assignment, they've given you a certain way of trying to populate, you know, I think I think your assignment, they already gave you the class width, that the class width is this. But in your final examination, they won't give you, they'll just give you a table. So I'm going to show you how to get the class width from a table. So this is the first way, right? This is the first way of calculating the cumulative frequency. Then the easier way of it is, we already know that here it's 1 and 1, right? So when you're coming to this one, you can say that the cumulative frequency of the current class plus, the frequency of the current class plus the cumulative frequency of the previous class. So if you say 2 plus 1, you get 3, right? Then you go to the next class. Then you say the frequency of the current class plus the cumulative frequency of the previous class. So you say 5 plus 3, then you get your 8. I normally like to use this method now because it's a bit easy, right? Then you come to the next one, right? Then you say the frequency of the current class plus the cumulative frequency of the previous class. So which is 6 and 8, and then you get your 14. Up until you get 200, right? This is how you populate, you know, your cumulative frequency, right? So this will prove to you like how many people, this will be the same as the sample size. So if you say 100 people took part, then you must get 100. If you say 50, then it must be 50. So the number of the sample size, that's the same number that you must get when on the last entry of the cumulative frequency. Then coming to the width, here already we were told that the width was 10. So that's why I went straight, because already they already did that for us. They already did the table for us, right? But how do you what? How do you calculate the class width? So calculating the class width, there are two ways of calculating the class width, right? Someone saying, so the frequency and the cumulative frequency should always be equal. No, they are not equal. If you check, it's only equal for the first class only, for the first class. But for the other classes, it's here is 2, here is 3, 5 and 8, 6 and 14. They're not the same. So this one you are adding the what? You are adding when you add them together. Oh, okay. I'm getting your question now. Exactly. All right. Yes. So the frequency and the cumulative frequency they are the same. So okay. So let me try to explain it this way. So when you add all the frequencies together, right? When you add all these frequencies together, you get 100. But on the cumulative frequency, you don't have to add them together. More like you just see the last digit. Just see the last digit on the cumulative frequency. So the last digit on the cumulative frequency should be the same as the total of the frequencies. But for now, don't worry, it doesn't. It's just something that I'm explaining that you should know, but it's not like you have to know it and things like that, right? I'm just explaining it for you. It's a verification way to show that what you did is correct. You didn't make a mistake somewhere, but it's not something that is examinable. It's not something that is going to be asked. But that was a very good question. though I didn't get it at first. All right, so now when we want to calculate the class width, what you need to understand is there are two ways of calculating the class width. So I want you to pay particular attention to what I'm saying, because when we get to these other measures of central tendencies, you need to calculate the class width from a table. So they won't give you a class width, they'll just give you a table, and then you have to figure out the class width on your own. So let's look at this thing here. That's why this thing is here, so that it can explain this issue of class width. So these are our interval. You remember this interval 0 to 9, 10 to 19, 1 hour, and things like that. So this 0 to 9 is divided into two segments. So there's what we call the lowest number in that range and the maximum number in that range. So this table is showing you for this range, this is the lowest number for that range. This is the maximum number for that range. This is the minimum number for that range. This is the maximum number for that range. So the minimum number for that range has got a particular name. It's called a lower limit. So it's the lower limit of the class, right? Then the maximum number for that class is called a upper class limit, or the upper limit of the class. All right, having said that, so each interval has got a lower limit and an upper limit. And this lower limit, these intervals, they are of the same size. From 0 to 9, it's 10. From 10 to 19, it's 10. From 20 to 29, it's 10. I know someone's like, is 0 to 9 10? Yes. If you count from 0 going to 9, it will be 10. Right? So that's why I always tell my students that most people, they've got this tendency of like, it's easy to guess class interval. You know what you do? You just say 9 minus 0, then you get 9. That's wrong. So you don't calculate the class interval by saying upper limit minus lower limit. That is wrong. If you were thinking that that's how the class limit was going to be calculated, then I don't want you to put it in your mind, because that's wrong, right? So someone is asking if the mark was 9.5. You remember the marks we were never given a mark like 9.5. You create your intervals based on the data that you have. So if there was a mark that have got, let's say, 9.5 or 9 point something, then the interval was going to be different from what we are saying. So the reason why we are having intervals like this is because of the data that we have been given. Normally, you know that people, on normal instances, people get whole number marks. Unless it's in a very extreme, if it's those lecturers or teachers that just want to be stingy with marks. But normally, if people are marking normally, they don't put like your decimals. You just get 10, or let's say it's a percentage, just get like 50%. You just get like 25%. You don't get it 25 point something, because still you're going to round it up into a whole number. So that's why you don't get a 9.5. Just to know, if there was going to be a 9.5, then the intervals are going to change. They have to accommodate all the numbers, right? They have to accommodate all the numbers. That's what you need to understand. So now we have our lower limit, we have our upper limit. How do we calculate the class width? Because if we say 9 minus 0, it's not giving us 10. Though if we count from 0 to 9, it's 10. But if you say 9 minus 0, it doesn't give you 10. So you can't calculate class width by saying upper limit minus lower limit. That would be wrong. And that would be very lazy of us to do that. But the most efficient way, or the only way of calculating the class interval, we have two options of it, right? So remember, we have our lower limits on the left side. We've got our upper limits on the right side. So we've got two ways. So you can either use the lower limits alone to calculate your class width, or you can choose to use the upper limits alone. So either of the two will give you the class width. So you have to choose. Do I have to lean towards lower limit or do I have to lean towards upper limit? So I'm going to do both so that you understand. So generally, we've got two formulas which caters for both methods, right? So if you are choosing to use lower limits alone, then the formula will be lower limit, right? So let me just choose first class and second class to be easy. But you can choose, so what you need to do, okay, so let me explain it by this way. So when you're choosing the classes, the two classes that you're going to use to calculate the class width, they must be neighboring classes, which means that there must be classes one after the other. So like, for example, I can choose these two classes because they are next to each other. I can choose these two classes, they're next to each other. I can choose these two classes, they're next to each other. I can't choose this class and this class because I've skipped two classes. So it only works for two neighboring classes, and it only works for consecutive classes. So for the sake of this example, I'm going to take the first class and the second class. So we're dealing with the lower limits, right? So if we have first class and second class, the formula for calculating class width, all right, okay, let me do this. Let me just say class width. Class width, it will be lower limit, right, of the second class minus lower limit of the first class. So what is our lower limit of the second class? It's 10. We come and take 10 here, minus what is the lower limit of the second class, which is 0. Then we get our 10. That's how we get our 10 here. So if I take this one and this one, you just say 50 minus this one, you get 10. If you take this one and this one, 80 minus 70 is 10. 90 minus 80 is 10. As long as they are neighboring, you still get the class interval. So if you choose any two neighboring, they must give you the same class width, right? Now, let's go to the upper limits. So the upper limits, that's the same thing again. You choose two neighboring classes. So let's say 4 and 5, right? So here I'll just say 49 minus 39, I'll still get 10. So the class width will be the upper limit of the fifth class minus the upper limit of the fourth class. There must be neighboring. Did you get that? I want to move from this point, being sure that I didn't lose anyone. Because this is a very, very important subject, this one, for the class width. Because you will see that when you go to calculate your median, your mean, median, and mode for grouped data, you need to calculate the class width. So are we on the same page? Before I move, just give me an indication. I just want someone just to give me an indication that you guys, you got it. If there's someone with a question, then please bring that up so that
we're all good.
Okay, perfect. All right. So that's all. That's all about the cumulative frequency, right? So most of the times you'll be given the table, so you don't have to worry. So someone might be like, so how do you come up with the intervals and things like that? Don't worry. Your module is not covering that. There's a way of doing it, but your module did not cover that, right? So you don't need to worry about that. I'm also sure if it did cover that, maybe I didn't see it, but your module did not show that, so it's beyond the scope, right? So they won't ask you. So normally what they do, like even in the final examination, they will just give you a table. We are going to do like mock exams at the end, so you have an idea of how your exam will look like. So you don't have to worry about how to calculate, how do you come up with the intervals and things like that. You don't have to worry about that because they will give you a table. So normally that's how they do this. Okay. Now let's go to so the first way of presenting data that we talked about is using a table. And the table that we're talking about is not just any normal table, but it's a frequency table, especially when you have grouped your data. So that's the first, another way of presenting your data. Then let's move to graphs and charts. So though table is better than the written format, it's still not a good way of presenting some type of data. So not all data can be put in a table, right? So that's where graphs and charts come in, because a table is just useful way to present detailed data. But now when you're talking about a picture or a diagram or a chart, it's now much more powerful if we want to focus our attention on a particular aspect, like for example, a dominant feature or a trend. So if you want to see, let's say, the peak, if you see this is a peak value, you can't talk of a peak value from a table. You have to show a graph or a chart and say, you see, this is the peak value. Then people see, oh, okay, it's on top of everything. Then if it's a trend, you see, we have been operating at a loss for this past years. They must see the trend. You can't see a trend on a table. Of course, on a table, you can have a rough idea, but sometimes one number can or someone is asking, yes, we are starting with the calculations. We are going to deal with the theory later, because chapter 1 and chapter 2 is theory, and theory it rarely comes. So we want to focus on what comes for now. Then theory will do it at the end. It doesn't affect anything. It doesn't affect anything. The theory, they're just explaining to you like the type of data, like quantitative, but doesn't affect the calculations or anything. So that's why we are starting on chapter 3. That's actually how I do all the lectures. So don't worry about that. Chapter 2, 1 and 2 cover them later. All right. So now we want to look at the different types of graphs, right? We can use to portray the data. So there's what we call a line graph. There's what we call a bar graph. There's what we call a pie chart. So we're going to look at each of these individually. So let's look at a line graph, right? So a line graph is very good when you want to show a trend. So this is the normal graph that we talk about. Draw a graph. People they are talking about the line graph. So how you draw a line graph is you would have, let's say, data on a table, and this is profit. And you want to show your people, you want to show your board that, guys, I think our strategy is not working because we are losing money. So you can't say, look at this table, guys, we're losing money. People will be like, what are you talking about? Right? Because, things, we can't see a trend there. Right? But if you plot this information in form of a graph, you can see that this is the same information, but here it's making sense. Like, yes, it's decreasing. So if I was a business manager, I would present the data in this format than this format. Because this format will complicate. I will have to talk a lot. You see 78 is greater than 65, and 65 is greater than 53. But if you could have just shown on a graph, people can see, oh, okay, yeah, things are decreasing there. You see, then it's easy for people to see. Because at the end of the day, you need to communicate the results perfectly. That's what is needed. So this is how you want, if you want to show a trend, or maybe let's say a dominant feature, a line graph might be good. Then here sometimes you can have what we call a bar chart. So let's say maybe you want to show in terms of quantity, like quantities, you want to quantify the number. You can use bar charts where a bar chart represents the magnitude. So you can see, okay, so this way the sales, they were a bit low. So and things like that. So this one was larger than this one. So the bars can help you, to quantify certain things. And then there are two types of the graphs. You can have one of bar graphs. You can have a vertical bars or horizontal bars. They still depict the same thing. All right. Then the last one that we are going to look at, the chart is what we call a pie chart. I'm not so sure why they call it pie, but I want to believe that these Americans, the pies from American people, I think they're always around. I don't know why. But to us, this is not a pie. This is a pizza, right? But they call it a pie chart. We rarely see pies that are cut as pizza slices, right? So, but in America, I think it's very common because I've seen, when they make some pies, homemade pies, they will be circular and then they'll cut it like a pizza. So that's why it's called a pie chart. So you can call it a pie chart or a pizza chart. So basically, this one is used when you want to depict a proportion in relation to the whole thing. A very good example of where we use pie charts is when you want to do what we call demographics. So let's say you are collecting data from a particular company. You want to see, let's say, the gender of people. So nowadays you have to put not only 2, but to accommodate some other people, you need to put, let's say, 3 or 4, right? Depending on the terminology that you use. So you can have male, you can have female, or you can have prefer not to say, right? Something like that. So let's say you can have 3, right? So that information, when you want to depict it, right? When you are, let's say, maybe now you are trying to communicate your results. The best way of communicating that type of information is through a pie chart. So a pie chart will show you, okay, so this segment are male, this segment are female, and this other segment, they prefer not to say anything. Right? So it's easier to see that type of data now in a pie chart. So what you are doing is you are showing a segment relative to the whole. So you're just showing that this portion is representing the males out of all the people that took part. So let's look at a very good example. So let's consider a father, right, who gives spending money to each of his 3 sons. So this is a father that has 3 children. So he has Josh, Matt, and David. Then obviously the eldest gets the largest amount. So he gives Josh 120, right? He gives Matt 80 rand. Then he gives David 50 rand, right? Now, if we want to see how much money Josh got in relation to the total money that the father spent, then what we do is we add all these 3 amounts, 120 plus 80 plus 50, then you get 250. So all in all, the father spent 250 on the children. But they were not given the money equally. They were given the money based on their the age, right? The eldest one was given more, the middle one was given middle, and the younger one was given the small amount. So if we want to see the percentage of the full money that Josh used, so you can say was given, so you can say 120 out of 250. So 120 out of the total of 250. So you can see that this origin here, Josh was almost given half of the money. It's not half, but almost half of the money. You can see from this region here. Then you can see Matt was given this region in yellow, and then the youngest son was given this region in dark brown. So it's easy to interpret data like this. So normally now, if people, let's say, were reporting on what, so this is what they call the legend, right? Then here there will be like 48%. So there will be a value here that's written there. So this one will be 20%. Then here it will be 32%. So you already know that mate was given 32% of the total money. This one was given 20% of the total money. This was given 48% of the total money. Basically. So that's how you work out with this one. Then I think for today, let's end here because now, okay. So there's still this histogram. All right. So let me explain what this histogram is because I thought that was the we were now getting into some calculations. All right. So a histogram now. So a histogram is a specific type of a bar chart. So why are we saying it's a special bar chart? It's a bar chart where you only display values from a frequency table. Remember that frequency table of the number of males and the ages. We had a table, remember? So if you want to present that frequency table in a bar-like chart, that bar-like chart is called a histogram. It's not just a bar chart. It's actually a specific bar graph called a histogram. So if a question comes and say, what is a histogram? Histogram is not a bar graph. It's a bar graph that display frequency distribution. That's what a histogram is, right? So I think there was a question in your study, in your assignment. I think that requires you to draw a histogram, if I'm not mistaken. That's actually so that question of the histogram, I think it comes after they asked you to draw a frequency table. Right. So you start with the frequency table, then the data from the frequency table is what you use to draw a histogram. Right. So a histogram is not only a bar graph, but it's a specific type of a bar graph that display frequency distribution. I hope we are all together there. But like I said, I'm just emphasizing this, but there are no questions in the final examination. Like I told you, you'd rarely get theory. So some of the things I'm just explaining for you guys to understand, but not that it's exam material. No, it's not exam material. All right, so let's stop here because now if I proceed to this part of the lecture, then we are getting into calculations. So I don't want us to get into calculations when our mind are so are so saturated. Normally, I want to start on calculations when everyone's mind is free, so that I take you when your mind is too fresh. I take you through all the process so that I don't lose anyone. All right. Yes, you do get slides. I think let me just send James all the slides so that they give you the slides. So don't worry, the slides you get them. I saw someone had their interest, unless maybe it was the same question. Right, if that's the same question, then that's fine. Don't worry about the slides. So I'll send you all the slides, and I try to use information within your study guide. If I just add here and there, I'll tell you that this I added, but I try to use examples from your study guide so that when you go and study also your study guide, you are not lost. All right, any other questions, guys, before we close the session? But I think well, everyone is on the same page, right? I think this was clear. This was easy, clear, right? All right, so there are no questions. All right, so guys, thank you so much for coming through. So we'll meet same time next week, right? For those that are coming for information management, we'll see one another tomorrow. But for stats, that's all for today. Have a lovely evening. Good night.
Thank you. Good night.
All right, thank you.
Thanks so much.
Okay,
Good night.
thank you.
Thank you.
Perfect.